All right, we're live. Hi, and welcome to the Serverless Guru Management for AI Systems webinar, everybody. I'm Jonathan. I'll be helping kick things off today. I'm joined by the fantastic one and only Almir, our newest head of security here at Serverless Guru. So you know you'll be in good hands. Sorry, Allstate. I think I may have stolen your slogan there. We'll be kicking off with a demo and showing you guys where you might be going wrong and how to potentially fix it, featuring maybe a special guest, OpenClaw AI agents. There's a whole ocean of of machine learning, right? While LLMs may be the most popular thing right now, like the coolest kids on the block, it's important to know how to secure yourself no matter what you're using, because as Almir always says, you can't protect yourself from what you don't understand. But enough from me. I'll pass the mic to Almir so we can get things going. You guys are in for a fantastic webinar today. And as always, sorry. If there's any questions or comments or anything, leave them in the comments and Almir will get to them. Sorry. All right. Now I'll pass the mic to Almir. My bad.
Thanks, Jonathan. Thank you. It's my pleasure, and it's always pleasure to see you as a host of this webinar. And thank you for the great intro.
Oh,
without further ado, let's get started with this. So welcome everyone. Today we are going to talk about security management for AI systems. So the main idea of this session is simple. The AI security is not only protecting the model. Production AI system includes data, pipelines, infrastructure, APIs, and whatnot, integrations, configurations, monitoring, and last but not least, the recovery process itself. And we have a nice demo about that as well. So through this presentation, we are going to look at AI security as an end-to-end discipline, not as a single control or single vulnerability category or something like that. We are going to talk about everything that makes these systems secure. So this is our agenda for today. We will start with a few short demo cases to make topic practical. So the reason for this usually because I'm doing these webinars, I talk too much, and then at the end of the webinar there is no time for a demo, and people are waiting, to see something, what they can identify with, something that can make them understand what we are talking about, and to give a context. So this time we are going, we are doing a little bit different. We are going to do the demo, but then we will go through the main parts of the AI system lifecycle. So, and finally, we will look into the security controls. So, as a little teaser, this is something, and please note that due to the ethical reasons, I'm not going to explain you how I made this. There is a repository, and it will be made public, but without some advanced configuration issues and hidden configurations that made this possible. So what you're looking here is the screenshot from the OpenClaw and request to see the list of available files, and then what I'm doing, I'm asking it to give me the content of the file. First, it says, yeah, I can do that because of the security reason, and then suddenly I got the data like there is no any security boundaries. I will show you this in a small practical demo. So in this demo, nothing is technically compromised. So the AI agent is functioning exactly as designed. So the problem is that it was given access to more data and more capabilities than it actually requires for a normal functionality. There is no exploit, no malware, no prompt injection, no nothing. It's just misconfiguration. So this is what people usually overlook. So Jonathan made an introduction. We are not talking here just about the large language models. We are talking about the developing. We are going to talk about the developing AI agents, training models. We are going to talk about using AI agents like OpenFlow and orchestrating them, and what misconfiguration from a security perspective um, means, and how things can go wrong. So the blast radius here exists purely because of configuration choices. Uh, so this is how security incidents begin. This is often the case, not always the same, but this is often the case. There is no sophisticated attack. There is only excessive permissions, meaning that you actually misconfigured something and gave more control than you should. So let me switch to the OpenFlow window. I'm going to stop sharing this screen for a moment, and I will switch to the OpenFlow tab. Here we have two different configurations. So this is that where we are asking OpenFlow to show list all available files. And due to configuration reasons, we can see customers txt, and we can see the project nodes, which are shared. However, when I ask for the content of the file, I got the content without any issues. So when we have the good configuration, and I will switch to another tab. Just bear with me for a moment. Okay, I'm gonna stop sharing this one, and going to switch to good configuration, and that's another tab. And I will ask OpenFlow to show me the list of available files, and we should not be able, hopefully, fingers crossed, we should not be able to see the contents of the customer's files anymore, and we don't even see customer customer file anymore. So unlike the previous window where you saw the list of all files that are available in that folder, actually, we are now seeing only the README file. So even if I try to get, because I know the exact path for some reason, even if I try to do this, hopefully, if the configuration is right, it will reject me. If the configuration is wrong, we will see the we will see the we will see the content. No, so no reply. The request file is out of scope and cannot be accessed. So the reason and the difference between these two is just how you configure and what permissions you are giving to a model. I show you at the very beginning of the presentation screenshot of the chat previously that I had for when the things were misconfigured, how I got the content, and even was able and I was even able to update the files that I shouldn't even be able to that I shouldn't have permission to access, not to mention the update itself. So another thing that I want to show you, and I will go back to the presentation, and that one is so the AI gateway trust boundary failure. So this demo is inspired by a real world vulnerability disclosed in an AI gateway product. So this is the actually vulnerability that is found in that has been found in light LLM proxy. So I will put the link to this vulnerability report in the chat later, or even Jonathan, if he's with us, he can paste the link from the private chat. So what was the issue here, and what is the actual problem? So the problem was that the model was compromised. Not really the model. So the the data were compromised, uh, not because the missing token validation. So token was valid. So the issue was the untrusted input was allowed to influence the validation process itself. What that means? Vulnerability itself was SQL injection. So the example that I'm going to show you, what happens when the system trusts external input too early. So whenever a user-controlled input can influence validation logic, the security boundary begins to fail. So what this actually means in the practice, and what are these failures that are happening today? We are back to basics. SQL injection is a classical vulnerability that is here since the beginning of the APIs. So to make this practical, I will switch to the demo itself and show you what actually happened during uh, that security incident. So I'm going to switch to the AI Gateway Trust Boundary demo. There we go. So, what is the problem? I'm not going to teach you about the SQL injection. If you are doing software development, you probably know what is it all about. I'm just going to show you what actually happened. So, this is the API used by the Light LLM, and in authorization header they were accepting token. However, somewhere in their SQL, they were building this they were building this SQL from string. So if you add something to the authorization header, so beside the token, um, when parameterized query is not used, what happens is that parsing this authorization header, and you get something like this. Um, you get the this is where this is what is injected into the authorization header. So this was not literally what was injected into the Light LLM. This is just to show you, to demonstrate what is the danger, how it can be dangerous if you are not validating the inputs, and if you are letting everything in without any validation, if you trust your inputs just like that. So if you add this, for example, into the vulnerable system, you will get one SQL query, and then you will get this one. You will get delete query that can delete your data, or your data can be compromised if you just add additional condition. So, for example, most of the systems are getting the user data based on the token, and if you have query that is that you are building with the strings, and then you suddenly get query like this, and then in response you get all your user data. Now imagine what you can do with if you know the database, and if you know what to look for, and what you are targeting. This is the basic example. You can find this everywhere on the internet, and I suggest you, if you are not familiar with this, which I strongly doubt if you are a software developer, but still have a look into the SQL injections and see how you can protect yourself. The safe foundation here would be to use parameterized query, and instead of passing the plain string, you will pass the parameter, and this this will be your parameter, and this will return nothing. There is no injection here, and everything is everything is safe. Going back to the third example, and this one will be quick as well. And that first, I will go again to the presentation to show you what is it Uh, what is it about? So this is my this is my favorite example because uh, there is no attacker involved. So unlike the SQL injection and the API demo, where you had a attacker which were exploiting the vulnerability and unsafe input, here there is no attacker. So nobody exploits anything. Nobody steals credentials. Nobody compromises model. So organization experiences an incident. Uh, and it restores from the backup. Restore complete successfully, everything is fine, system appears healthy, application works, happy days. Well, not so fast. Uh, Security has degraded silently because the restore point was from the latest backup. Latest backup does not mean the latest known good state. So this is something that you need to pay attention to, and this is why you need to test your backups and the recovery process. So we restored the backup, or organization restored the backup from the last available state. Fine, backup was great, but the application or the data itself were compromised in that backup. So 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 validating backup, is it successful or not, is not enough. It is only one control. So can you restore your backup? Does it succeeded? Was it successful? But that is not enough as a security validation. So going back to I will switch to my terminal now, and I will show you just quickly how that can look like in the real world scenario. And what I'm doing in the background is actually the uh, is actually real restore of the OpenClaw demo that you have seen before. So what am I doing? I'm restoring latest backup, which is not the last known good backup. So hopefully I will be able to share this one. Yeah, okay. We are in. So I have a couple of scripts, and I will check the security. So this is the open flow security posture. Everything looks fine. So now I'm going to restore not the latest, not the known good. I'm going to restore the latest backup. So I restored my backup, and now the OpenFlow is running. But however, um, what is happening is that it has bad configuration. The one that I initially show you, where you can access files and everything. So I saw the issue, and the latest version was not okay. So I reverted. I experienced the incident. I restored the backup, and what happened? I still have an issue. If I haven't tested this, it would be a problem. However, if I do restore known good backup, and if I test this one, now things are fine. Uh, and this was just a quick demonstration, and I will share the source code of these things that you can try for yourself and play with the demo and play with your own files. But please note, do not use your real credential. Do not use your own real data. Do this in the sandbox. Do this in a folder with the fake data, with the mock APIs and the things, because this can easily get out of control. Now we are going back to, so if you are interested in these how to prevent this incident, please bear with me. with the rest of this as we are going to with the rest of this presentation. So speaking of that, we are going to the slides uh, again. So now that we've seen the demo scenarios, we can talk about the broader concept. So what is actually security management for AI systems? That's so the definition would be something like a set of tools, processes, controls used to protect um, AI systems across their entire life cycle, or as we like to say, end to end. So it includes protecting the model, but also the data, the training pipeline, deployment process, runtime environment, APIs, and the other things. Everything end to end, everything from the development to the production release, and even later. So the important point is that AI security combines traditional security. So this is something that we so this is the term that some people, including myself, are using today um, to refer to pre-AI era security. So that is a kind of traditional application in cloud security, and there now additionally we have AI specific risks such as model poisoning, data poisoning, model theft, drifts, or unsafe model behaviors. Some of these things you have seen in the demos. So in practice, many AI incidents are not caused by model itself. They are caused by weak controls around the model. And also, I want to say one thing. I'm not saying do not use AI, do not use models, do not train models, or and nothing like that. I'm just telling you to use the common sense and to pay attention to security even more than you paid before, because the things are easily getting out of control. So we are going to talk about we are talking about protecting this software development life cycle, and first thing we are going to mention are model weights. So those are the learned parameters of machine learning models. So you see in the when you look into the model names and the versions, you will see some text or 7B, 14B, 27B, and those kind of numbers. So what that means? That is actually like number of parameters, like 7 billion, 14 billion, or whichever number is there. So they represent how model is smart. It's not always the case, but usually the more parameters you have, the model is better. Doesn't have to be always, because there is something with training as well and the quality of the data and other things, but that represents um, the behavior and the decision making capability of AI systems. So in many organizations, model weights are also intellectual property, and this is very important. They may represent the months or years of data collection, training, optimization, and the domain knowledge. So you don't want to lose that. You don't want to expose that to the public. You don't want to give access to other people to train their models on your data that you own. So if model weights are stolen, the organization may lose competitive advantage. If they are modified or replaced, the system may continue running, but produce incorrect or unsafe results. So that is why model artifacts files should be protected like critical production assets. So then the next thing already mentioned, because you can have model weights without training data. So this is the training data directly shapes how the model behaves. If the training data is incorrect, manipulated, poisoned, or poorly labeled, uh, the model may learn the wrong behavior, and you need to protect this. This is especially dangerous because the model may still appear technically functional. So everything seems to working correctly, but it may return, and it may still return predictions, but those predictions can be systematically wrong. So, for example, incorrect labels may cause false positives, false negatives, or hidden bias in a production. So imagine quality control in a production in a production on a production lane. So in a car industry, for example. So if the data is manipulated, and we know that lots of processes are now automated, there may be some quality control can pass because the data was compromised, and the things that should not go that should not be overlooked are overlooked during the testing. So training data security is not only data governance problem, it is also a model integrity problem. So if you are developing models, you need uh, you need to pay attention on this. So the training pipeline is where the data, code, dependencies, configuration, and um, automation come together to produce a model. So it's a same in a classical software development like life cycle, except the final artifact or product is not the application; it's the trained model. So um, from a security perspective, and this is what we are talking about. We are not going to talk about the training model itself, but of the development life cycle. So from a security and the security from the security perspective, of course. So from a security perspective, this makes the training pipeline critical supply chain component. So if the pipeline is compromised, an attacker may not need to attack the production system directly. They can influence the model before it is deployed. So uh, you have probably seen a lot of attacks related to this, and they've been named supply chain attacks. So this is nothing new, but it became it became one of the largest vulnerability, one of the biggest vulnerability in in a training model in this system. So this is why dependency scanning and secret scanning and artifact signing and the dataset validation and reproducing backup restore procedures, recovery procedures are important parts of the AI security. So uh, if you want to trust the model, you must trust the pipeline. So you have to pay attention to this. Now, finally, the deployment. So after pipeline is done, so it's like that. That's the process of moving a model into the real environment. Fine, we trained the model, we built everything we wanted to build. Now it's time to deploy it to the production, to the final users. We want to start making predict. We want the model to start making predictions and maybe making some decisions on our behalf. So at this stage, integrity and authorization are critical. um, we need to know which model was deployed, who approved it, where it was deployed, is and whether the deployed artifact is the same as one that is tested. So this is also very important. So the if there is a something in between, so the artifact that we built doesn't mean it reaches the production. It can be swapped in the middle of process. So weak deployment controls can lead to model replacement. It can lead to outdated models running in production. It can lead to configuration drift or inconsistent behavior compared to what we seen during the development and the testing. So uh, this is what connects the development with the real world operation. Now the inference is where AI systems produces outputs in real time. So this is often the this is often the most critical part of the system because it interacts with the live users, live data, or live operational processes. So security risk in this layer include runtime manipulation. Um, we can experience here denial of service. Um, we can have silent degradation, which I shown during the backup restore demo. So we may think that we restored, or actually we restored the latest backup, but what we were not aware that the latest backup was also compromised, and this is what is called silent degradation. We don't know that it actually that the system is degraded. From whichever perspective, but talking about the security, we are not aware of that if we haven't tested tested it. So uh, the key challenge is that inference failures may not look like traditional application failures. Again, using the traditional application as a as an explanation for to distinct the application development from the model development. So the system may continue responding, but the quality or safety of the output may not be uh, what we are expecting. It may um, degrade. So the security demo about the API gateway token injection, SQL injection, and token issues with the light LLM. Uh, so this is how it happened. So the most AI systems are exposed through APIs. So that means that the API layer becomes one of the main security boundaries uh, between between uh, between users and models. Of course, it's the same with the users and the application. But if this layer is poorly protected, attackers may abuse inference endpoints. So they can try various things like they can try model extraction. They can and that is closely uh, closely related to data protection as well, because uh, there may be some reverse engineering in the process involved. So they may overload the system. They can manipulate inputs, um, or they can access functionalities that they shouldn't have. You know, like admin APIs for controlling users or controlling the data. So AI APIs needs to have the same security controls as traditional APIs. So you must have authentication, you must have authorization, you must have rate limiting. This is very important uh, in the context of the resource use, because something that we are working on and that we are testing. One of the things in SLS Guru is the cost impact for our clients, for ourselves, for everyone. You need to be aware that, and this is the thing today, that spending tokens can cost you a fortune. Underlying infrastructure can cost you a fortune if somebody is abusing your infrastructure. So before we had the attacks to to use your instances for Bitcoin mining. Now we have a situation where people are targeting people malicious users are targeting vulnerable APIs and exploiting tokens. So they are literally spending your money. This is why you need to protect your system. And last but not least, AI APIs needs to be monitored. You need to have logging. You need to have monitoring developed. Um, but there are also some AI specific awareness that is different than with the classical APIs. Um, because output of the model can create additional business risk. If you are relying on the data, if your sales or finance relies on the data, compromised API can do the the real damage. And again, this is related to things like agent orchestrator, OpenClaw, for example, um, where you have these agents running 24/7, which is kind of thing. Lately, uh, you run these agents, but these agents often depends on third-party services. And if you are developing your systems, you are accessing those third-party systems. And those third-party systems are not only limited to model providers. They could be on model providers. They could be different cloud platforms. They can be SDKs. Uh, there may be those your email client or messaging apps or whatever. So if third-party service is compromised, misconfigured, or it has more permissions than it should, blast radius and the impact can be huge. And the impact can propagate into the AI workflow, and this is a recipe for a disaster. So you need to be aware um, about about the basics and advanced IAM access as well. So you need to do permission review. You need to audit logging. Um, you need to do all the things that you used to do in the classic application development security protection, but also you must think about the new threats and things that this AI era brings with it. So, what are the security controls that you can use to protect the AI systems? So, the controls on this slide are the main building blocks for protecting AI systems. Um, Access control define who can access models, data, pipelines, and deployment environments. So no different than you have in a classical application security. Integrity controls um, make sure that artifacts have not modified or replaced. Secure CI/CD protects the pipeline itself. So temporary credentials and all the stuff that I hope you are using in your pipelines today, in your GitHub Actions or AWS Code Pipeline or GitLab or whatever you are using. Uh, um, so and there is a data security, of course. So this obviously protects the training and the runtime data. Um, so the runtime protection, this is actually the runtime protection monitoring and anomaly detection identifies issues and unsafe behavior in production. So, as mentioned before, you need to be aware. You need to constantly monitor and look into your logs, observe your system, and see how it behaves. And if you're already using AI systems, you should use anomaly detections and be aware of what's going on. So the first thing that comes to my mind in as anomaly detection in that you can use today if you are working in the cloud, if you are working with AWS, check the cost anomaly detection and see which service suddenly um, started spending a lot more than it used to. So so the concept itself is not limited to AI models. There are different use cases, and this is something that you can that you can and that you should implement in all your systems everywhere. And I mean, it's do I ever need to mention the security and the credential management? So not exposing secrets. I mean, it's ridiculous talking about this today because everyone in 2026 should know about it. But we were witnessing lately that credential leak, hard coded credentials, and the stuff. So keys, tokens, passwords, everything that is considered secret, or that allows you access to something that you don't want everyone to access, needs to be carefully managed. And one important, probably the most important thing here is that this is not cherry picking. You cannot just take some of these controls and say, yeah, we're good. No, the single control is not enough. You need to defend your system, to protect yourself, to protect all the systems in depth. So you need to apply all these security controls, and if there are specifics within your organization and the system, you need to make sure that everything is protected. Um, so there is a another thing that is very interesting to me. So it is and I mentioned this in production. I mentioned the example of the car industry, for example. But when you're doing Internet of Things, you have many edge devices, and these are especially sensitive because they often run outside of fully controlled environment. It can be cloud environment, or your or somewhere on premise, but usually these devices can be somewhere in the field. um, so the example include Jetson devices. If you don't know what it is, I strongly suggest you to have a look. It's very interesting. Various embedded devices, industrial systems, or camera-based inference systems. So like security systems. Uh, uh, think think highways and uh, and uh, and even border control and or quality control in the on the production lane. So those are all camera based inference systems. So the on this device, model integrity is critical. We need to know that the deployed model is the approved model. So if the model is not okay, no matter how expensive or good the camera is or device is, we're not going to get the meaningful results. Input validation, critical. So devices may process may process real world sensor data or camera data, and if there is no input validation, somebody can tamper with the input, and you know what can happen next, or you don't. But I don't want even to guess. So protect your inputs. Do the validation all the time. You saw the SQL injection demo. Because if the module or input stream is compromised, the system may continue running while producing incorrect results, or results that attacker wants you to see, wants to show to you. Uh, for the edge AI, security must include artifact hashing. It should include control development, device hardening, and also runtime validation. And as for the backend infrastructure, this is something that is very well known. If you're following this webinar, you are probably working in a cloud, or you heard about the cloud if you are from a business. So the backend infrastructure usually stores models, data sets, configuration logs, and all the deployment automation. And this makes it a high value part of the AI system. um, so you must use encryption. You must restrict storage policies. Least privilege IAM is a must. Control the deployment permissions. You cannot just um, give your system like permission to everything and hope for the best. And as mentioned before, you need to do audit logging. So only authorized services or pipelines should be able to deploy models or modified the sensitive assets. And if you misconfigure backend infrastructure, then there is a danger of exposing models, credentials, or 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 even allow runtime access. And referring back to the OpenClaw demo, uh, you saw only a small part of what could happen if you misconfigure your backend infrastructure. So in many cases, this is where the systems most system fails. So it's not sophisticated, like AI specific attacks. Somebody, like doing something very smart that 1% of people can do, or even less. It's usually something that slipped away because we haven't paying enough attention, or we haven't tested things enough, and this is what attackers are targeting. So again, so the labeling platforms are often underestimated, but labels are deeply influence what the model learns. So if you don't know what the labels are, so when you are training the models, and in object detection, for example, you want to teach the model to recognize pizza, for example, and to recognize pizza, you need to feed image lots of the data representing different things, but you want to mark what is pizza and what should be considered as a pizza, and then you are doing that using labels, and if the labels are not correct, the model will not provide correct results. So only approved labels in datasets should be used for production training. You cannot allow um, unapproved labels or unchecked labels to get into the systems. So you need to audit who created label, who changed the label, who reviewed it, and who approved the labels. So the labeling security is part of the model integrity. With the bad labels, you integrity can be compromised as well. And finally, um, supply chain attacks already mentioned. This is no different than in the traditional applications. The issue is that code review quality has been degraded recently, at least from what I observed. So the supply chain risk is real. It was always a thing, and you should had you should have this protection everywhere in traditional applications, and especially in deploying model. So dependency scanning helps identify vulnerable packages. Um, there's a thing called the software bill of materials, and you can generate this and improve visibility. What components are included in your systems? You need to be careful what dependency you are adding. You need to use fixed versioning um, package in your package management. Also, you need to do secret scanning for secrets, so to prevent accidentally exposing credentials. Unfortunately, we saw also recently a couple of very noticeable cases of leaking credential accidentally. So in AI systems, you're not protecting only the code, but you must protect the full model life cycle and all the things we mentioned: labels, data, training stuff. So and finally, these are the references. So these are the all the things where I was gathering the data and the information for this presentation, and fact checking the things that I talked about. So I strongly recommend it to look into these links, and these references will provide you uh, useful starting points for AI security, for supply chain security, and security controls that were mentioned. So as the purpose of this list is just to give you practical sources that you can use. Hopefully, we are going to share this along with the um, with the source code for the three demos. So if you want to get this and to see this reference list and to try demo for yourself, follow Serverless Guru on social networks. Follow us on LinkedIn or whichever social network you are using. We are everywhere. So and um, you can find very good content, and you can find references like this that can uh, that can help you, that can save you time, and that can help you apply apply security in your own own system. So thank you for your time. I hope that this session showed that AI security is not a complete separate discipline from traditional security. Use common sense, apply security controls, take care about all parts of your systems, and stay safe. So thank you very much for your uh, attention. So back to you, Jonathan.
Hey, thanks, Almir. Fantastic presentation as always. And if anyone has any questions, always feel free to reach out to us on LinkedIn. I know Almir isn't on there, but if you send any questions to Serverless Guru or SLS Guru there, we can always forward it over and make sure that we get those answers for you. The one question we do have is from Cool Kim. Is the configuration done locally? I'm not sure if this is kind of early in the presentation.
Yeah. So the configuration itself, well, it depends what you consider locally, of course. If you are hosting model, so you created a model that is doing something, or you created a agentic workflow. Um, you are configuring, this is part of your backend system. So for me, it is a local configuration. It's not the configuration that is a public. So that is a configuration of the system, uh, that is a protected part of the system. You don't want to allow people configuring your system. That is something that developers are doing, administrators, operations are doing. That is not something that is a public. So speaking locally, so if you're serving modules to your users, it doesn't matter if you're doing this on premise. You're still configuring this on the backend. So you have your enterprise organization, and you have your infrastructure on premise, and you are serving your APIs. Configuration is done locally. In that on the backend. I would use term backend because it's not on my computer. If I'm serving this to the customers, the configuration is is done on the backend, and it doesn't matter if your infra is on the cloud or on the premise or wherever. If you have users, if you have customers, you are configuring that on the backend. I
Perfect.
hope that answered the questions.
Perfect. Yeah. If there's any other questions, feel free to let us know here on the stream, or like I said, reach out to us on LinkedIn or on Twitter. We're also on there, same as LinkedIn sls.guru. So thank you so much for your time today, Almir. This was great, and I'll let you know if there's any questions that come up.
Yeah, there is a one actually. I see the monitoring signal. What monitoring signals or checks do you recommend to detect model behavior?
Oh, yeah,
Uh,
there we go. Sorry,
yeah,
Buffer made it.
yeah, that's the one. So the last one. So um, so there is a specifically for the in a traditional applications, or in a model training. Uh, there is no something written in stone. Yeah, this is the model behavior you want to check. You are If you are training your model, you have a specific predictions in your mind that you want to that you are expecting from the model. So you need to have those. You need to test that behavior. but that is the last step. So you need to make sure that your data is not compromised. You need to make sure that your full end-to-end development life cycle is not compromised. Your labeling, whatever you are doing, and finally, it's the same like in a traditional application. Do the smoke test. Do the test of your models. Do test the predictions. Test what do you expect, and what the model returns. So there is no I cannot tell you test this specific behavior, because model that I'm using can be different than the model that you are using. So that is the difference. One few standard things that you want to test, obviously, is that your files are not exposed. If you have some data, or if your model doing something very sensitive, which I would not really recommend, but people are doing different things. You need to make sure that your PII data, for example, are protected, so that your system is not leaking that data. You need to make sure that the system will not accept unvalidated data, to prevent these SQL injections, to prevent a different kind of attacks. I hope that answers your questions. But it's a really good question, and it's a broad topic. It requires really separate webinar for testing, for hands-on testing on the model behavior. Okay.
Perfect. Thank you so much, Buff Tomato. Almir, is there any more you'd like to add?
No, no. As you said, there is. So we have our SMS Guru social networks. Reach out to us, and somebody will answer. If I don't know the answer, there are very smart people in the SMS Guru. They will know the answer, but you will get your answer for sure. Somebody will answer. So don't do not hesitate. Ask us anything.
He's being modest. He definitely does know the answer. So if you have any questions whatsoever, let us know. And Almir will be the one specifically to get back to you. Just no pressure. I appreciate you so much, and thank you all to everyone who watched today. You guys are the best, and if you want more live content, feel free to give us a subscription, or sorry, subscribe to us on YouTube. We're going to be doing webinars, until the end of time. So if there's anything else that you'd like us to do, or you'd like to see, feel free to let us know too, on LinkedIn and Twitter, or on YouTube itself. And we'll see you on the next one, guys. Thank you so much.